Hello, my name is Manoj Verma and I am from Mumbai in India. I have more than 30 years of teaching experience in chemistry, and on this channel I will be discussing topics and question papers related to the AS and the A level of chemistry, and hope you will benefit from my videos. Thanks for joining, and today I am going to discuss some past paper questions on the mole concept. So, are you ready? So, let's start with some mole concept questions. So, right away I'm going to start. So, this is like your questions. So, you see that this particular question is based on mole concept and it has been taken from the paper. As you can see that this is the October November 2012 paper, and it is the paper variant 21. So this is what we are going to discuss. So let's see what the questions are and how difficult it is to solve it, or you find it easy, that we will come to know. So zinc is an essential trace element which is necessary for the healthy growth of animals and plants. Zinc deficiency in humans can be easily treated by using zinc salts as dietary supplements. One salt which is used as a dietary supplement is hydrated zinc sulfate ZnSO4.XH2O, which is a colorless crystalline solid. Crystals of zinc sulfate may be prepared in a school or college laboratory by reacting dilute sulfuric acid with a suitable compound of zinc. Give the formula of two simple compounds of zinc that could each react with dilute sulfuric acid to produce zinc sulfate. Right? So you have to think about two simple compounds of zinc that could each react with dilute sulfuric acid to produce zinc sulfate. So what could those compounds be? What is your guess? So let's see what those compounds could be. It could be any one of them. It could be zinc carbonate or zinc hydroxide or zinc oxide. So any of these compounds can be used for preparing zinc sulfate, right? So, but you should not take zinc directly, but you should take a compound. So these are the compounds of zinc. I think you understood the answer. So let's go to the next question. A simple experiment to determine the value of X in the formula ZnSO4.XH2O is to heat it carefully to drive off the water. So see, this is the salt that they have taken, ZnSO4XH2O, and on heating it, all the water has been driven out and you get the zinc sulfate solid, right? So uh, basically our aim is to find out the value of X. That means how many water molecules of crystallization are present in this salt, whichever salt you have taken. So a student placed a sample of the hydrated zinc sulfate in a weighed boiling tube and reweighed it. He then heated the tube for a short time, cooled it and reweighed it, and when cool, this process was repeated 4 times. The final results are shown below. So see what they found out. Mass of the empty tube in gram was 74.25. Mass of the tube plus hydrated salt was 77.97, and mass of the tube plus salt after fourth heating. Now why fourth heating? Because you have to drive out all the water. So you are ensuring that all the water has been driven out. So now you are left with obviously the mass 76.34 gram, which is obviously less than the mass of the hydrated salt because of the removal of water, but obviously it is more than the mass of the empty tube because there is some zinc sulfate which is present in the empty test tube. So why was the boiling tube heated, cooled, and reweighed 4 times? So what is the purpose of doing it 4 times? So what is your guess? Obviously, it is being heated and cooled 4 times just to make sure that all the water has been removed out, because if you heat it less number of times, maybe some water is still there and therefore you are not getting the anhydrous salt. So the answer is obviously to ensure all of the water of crystallization had been driven off, or we have now reached a constant mass, that is, there is no more of the water of crystallization and only the zinc sulfate part, the anhydrous part, that is only this part is now remaining in the test tube. So I think you understood this. So now let us do the calculations. Calculate the amount in moles of the anhydrous salt produced. So first you have to find out the mass of the anhydrous salt. So obviously if you will subtract uh, sub subtract the mass of the empty test tube from the mass of the test tube plus the dry salt, that is 76.34 minus 74.25, should give you the mass of the zinc sulfate in grams, but then you have to find it in moles. So what's the formula to find it in moles? You must divide the mass by its molar mass. So let's see. So we will have to find out the molar mass. So the mass is this, which I already told you, and then the MR of zinc sulfate. So you will take these masses, atomic masses, from the periodic table. For zinc it is 65.4, sulfur is 32.1, 4 times oxygen add, and this is the MR of zinc sulfate, right? So if you don't take 65.4, you could even take 65 or 32, right? So then you may get this value 161, that is also acceptable. Now obviously to find out the number of moles of the zinc sulfate, the mass that you obtained over here will be divided by the molar mass, and therefore this is the number of moles, which can be written as 1.29 to 3 SF times 10 raised to minus 2. So if you use this value, right, then if you use this value instead of 161.5, use the value of 161 round. If you round it off, then this 1.29 times 10 raised to minus 2 will be 1.30 times 10 raised to minus 2. Now what is the mass of the water driven off? So let's see what is the mass of the water driven off. What are you going to subtract? So let's see. If you see that this column shows zinc sulfate with water, because this is hydrated, and this shows only the mass of the zinc sulfate after the water has been driven off. So obviously if you subtract 76.34 from 77.97, you should get the mass of the water which has been driven out. So let's see this. What is the value that you get? So it's pretty easy. So as I showed you, that you have to subtract this, so you get the mass of the water, but again you need to convert it into the number of moles, and the MR of water is 18. So you divide it and you will get the number of moles of the water which has been driven off, and it gives you 9.1 into 10 raised to minus 2. If you write it in this form using 1 decimal place, you will get this answer. Okay, so now you got the moles of zinc sulfate. See, you got the moles of zinc sulfate, you got the moles of water. Now you know the mole ratio. That means this is the moles of zinc sulfate and this is the moles of water. So now if you have to find the ratio, then you let us suppose that this is 1 mole. Instead of this, let us suppose that it is 1 mole. So how many moles of water, right? So by the this unitary method, or uh, if you just do simple algebra, it comes out to be 7.054. But you cannot have a fraction of the number of water molecules, so you round it off, so you get 7, and therefore you got the answer that the value of x was 7. So I think this is the way you had to do. So I think you understood this question. So let's go to the next question and see what was the next part of the question. So this was based also on the moles. So now, for many people, an intake of approximately 15 milligram per day of zinc will be sufficient to prevent deficiency. Zinc ethanoate crystals, this is the formula of zinc ethanoate. You see 2 over here because the valency of zinc is 2. This is the water of crystallization and may be used to provide you with the zinc that you need. You may use this particular salt uh, to get the zinc. Right. So what mass of pure crystalline zinc ethanoate, so this is the MR, will need to be taken to obtain a dose of 15 milligram. So what is the mass that you will require, because you need 15 milligram of zinc. So how much of this salt you will take, how many grams of this salt you will take, so that it contains the 15 milligram of zinc that you need for your body. So that's not so difficult. You see that in this mass, the total mass, what is the mass of zinc? So you will have to use the atomic mass of zinc, and then you can easily get it. So let us see it over here. Right, so see, you have found out the number of moles, because the atomic mass, the relative atomic mass of zinc is 65.4. So this see, this is 15 milligram, and you must have the mass in grams. So please, you'll have to make this change, right? You'll have to make this change. So 15 milligram, but we cannot take milligram. So to convert it into gram, you'll have to divide it by 1000. So it becomes 0.015. So you will have to take 0.015, and then you will have to divide it by the 0.015, and then you have to divide it by the AR of zinc, and you get the number of moles of zinc which corresponds to the 15 milligram of zinc. So this is what you get, right? So the mass of the crystals will be how much? So for that, mass of crystals will be the number of moles of zinc, right? And then you have to get to what is to this 219.4. This 219.4 is obviously the molar mass of the zinc salt. So let's see this. See the MR of zinc ethanoate, right? See, the MR of zinc ethanoate is this, right? And you got the number of moles of zinc. So how many moles of this you require, right? So see here, it is like the ratio is here 1, right? So you just multiply this by the molar mass, and then you will get the moles of, see, you will get the mass of the crystals, which is this. Now this is in grams, right? This is in grams. So if you want it in milligrams, then you have to multiply it by if you round it off 0.05, and then multiply it by 1000 to convert grams to milligrams, so you get milligrams, 50 milligrams, which actually means that if you take 50 milligram of your salt, that is the zinc acetate, see, if you take 50 milligram of this zinc ethanoate, 50 milligram, so that in this 50 milligram 15 milligram of zinc will be present, so it will be sufficient for your requirements because you require 15 milligrams. So if you take 50 milligram of this, it will be sufficient to give you the 15 milligram of zinc that you need. If this dose is taken as a 5 centimeter cube aqueous zinc ethanoate, what would be the concentration of the solution used? So now we have to find out the concentration. So concentration is in mole per dm cube, so that is not so difficult. So see, you got 50 milligrams, right? So concentration is that you have to use how much quantity of water. See, this is the concentration of the zinc ethanoate which you got over here, 2.29, and then you have to, how much water he is asking you to add. Just see how much water he is asking you to add. So he's saying that you are going to take, see, you are going to take 5 centimeter cube, 5 centimeter cube. So the volume required is 5 centimeter cube, but centimeter cube needs to be converted into dm cube, so that will be 0.005. So that, because you have to take it in dm cube, so this is the moles and this is the volume in dm cube, which gives you this value, which can be simplified to 4.58 into 10 raised to minus 2 mole per dm cube. So if you take this concentration and then after that you take that 5 ml of this concentrated solution, so in that 5 ml of this solution you are going to get your 15 milligram of the zinc which you wanted as the daily requirement. So I think you understood the practical application of your knowledge of chemistry, how it can be used for medical purposes, so that the doctors can decide that how what concentration of zinc ethanoate should be prepared. It should be prepared of this concentration, so that if you take 1 spoon of it, 5 centimeter cube of it, it will be sufficient to get the daily requirement of 15 milligram of zinc. I think now it makes a lot of sense how this problem was done, and hope you understood. If you understood and liked it, like the video, please comment and share this video as well as like it. Thanks a lot for watching.